Welcome to our Hi, welcome to our final Farmel AIA Studio. We'll be taking you through our problem statement, solution, precedent, project methodology, datasets, classification and training, and finally the application. In recent years, food insecurity within the city of Melbourne has been recognized as a growing health, economic, and social issue, largely driven by growing poverty and financial hardships. In 2021, the City of Melbourne Social Indicators Survey indicated that 1 in 3 residents were experiencing food insecurity. So the solution for this would be factors like sun hours, temperature, and soil typology play a major role in the assessment of tree survival and choice of the right edible tree species to be planted. Hence why, next please. The solution would be basically planting edible trees, primarily through evaluating areas for tree planting, suitability, and populating them with edible trees. Next, replacing the aging trees with edible ones to increase food production, and finally, introducing edible trees within the city districts of Melbourne. Next. There are many fruit and citrus trees that are well suited to Melbourne's climate, including apple trees, pear, figs, olives, and so many more. Next. Our primary objectives is basically to provide locals with more sources of food, provide them with access to nutritious food, and finally suggest new areas for plantation. One of our precedents is basically the edible trees that has been populating the streets of Valencia. And for our project methodology, we will be starting with a climatic machine learning where we will take datasets of street pollution, sun hours, soil typology, the age of trees, and the location of existing trees. Our process would basically be overlaying the datasets to obtain zoned locations within districts suitable for planting edible trees, having an output that will basically be evaluating and predicting suitable locations for tree planting. Those are basically our data sets that we will be using in terms of edible trees, sun hours, temperature, soil typology, road segments, and existing trees.
For our classification model, we have 7 types of species: pear, lemon, cherry, fig, apple, tea, and olives. With these 7 species, we will classify them based on sun hours, age, thermal temperature, street pollution, and soil typology. The scatter plot shows us the distribution of tree species with respect to sun hours and age group. This scatter plot shows us the distribution of tree species with respect to temperature and street pollution. And this with respect to the soil typology. We have given an integer to the soil typology to make the classification model more easier. Here we have located the trees in the city of Melbourne based on their age group. The trees are plotted as per the age group, where the blue markers are the younger trees and the red ones are the older trees. So this is for apple and pear, fig and olive, lemon, tea, and cherries. For the street pollution, we have considered that primary roads are the most polluted than the tertiary and the secondary roads. This shows the pollution, street pollution in the primary roads. This shows the street pollution in the secondary roads. And then there's a combined street pollution of all the 3 typology of roads. This is the temperature map of the city of Melbourne. And we have located the sun hours for the city of Melbourne as well. And this is the combined data set that we will be using for the classification model. These are the scatter plots that we acquired after cleaning the data. This has been plotted with respect to the species, to the sun hours, and the temperature. And this for the soil typology and the street pollution. We can see here that the peaks have different features which are confounded, and the correlation between these features is low. If you can see in this confusion matrix that some of the classes are confused while some classes show better classification. As I have seen earlier, we have removed the data sets of cherry, tea, and olive, as the precision of prediction was 0. The spider plots tell us that, for example, for pear, the street pollution and the thermal are the more contributing features, whereas for the lemon, it's more of sun and the street pollution. And for the fig, it's both the sun as thermal and the street pollution. And for the apple, it's it's the street pollution, temperature, and the soil typology. Now let's look at the application. Thank you.